Do you hear me? Give my creation life!
Good day, everyone, and welcome back to TMac FPV, your home for your journey to better FPV fun, flights, and racing stuff. Last video, we assembled our components into our micro FPV 2.5-inch drone, the FlexRC Ascent X 2.5. If you missed that video, a card will pop up in the upper right-hand corner of this video with a link to it. Go ahead and watch it. This video will be giving it the ability to fly by programming it with the latest version of BetaFlight and also setting up its motors and ESC with the BLHeli suite. Let's do this. So we've got our BetaFlight configurator opened up on our desktop, and the first thing we need to do is connect our quad to BetaFlight using the micro USB cable. Now, one of the first things I wanted to show you on this setup page is that the 3D model should depict the orientation and the flight movements of the actual quad itself. So if I take the quadcopter and I pitch it forward like this, you should see the 3D model pitch forward, when in actuality you do not. It's rolling to the left. If I pitch it backwards, you should see the 3D model pitch backwards. It does not. It rolls right. If I roll right, the model pitches forwards. If I roll left, it pitches backwards. So, what's wrong with this picture? Well, just because I wanted to ensure that the battery cable of the quadcopter was coming out the back instead of the side, I switched the flight controller around by 90 degrees from what it was intended to be initially in the design of the flight controller. The flight controller and the ESC both have little white arrows on them showing you the front, or what the designer intended to be the front of the flight controller and the ESC, and normally put those arrows pointing towards the front of the quadcopter. In my case, I did not. I rotated them so that they pointed to the right of the quadcopter, or 90 degrees clockwise from the front of the quadcopter. So the first thing we need to do in order to get this 3D model moving in the same direction as our quadcopter is we need to go to configuration. Over here in the board and sensor alignment area, since we rotated the flight controller in the horizontal or the yaw plane 90 degrees, we're going to change this yaw degrees for the board and sensor alignment to 90. Save and reboot. It reconnects. And now what we should have is when the quadcopter pitches forward, the model pitches forward. Look at that. When the quadcopter pitches back, the model should pitch back. When it rolls right, the model rolls right. When it rolls left, the model rolls left. Yaw right, yaw left. So now we have the flight controller set up properly in BetaFlight. The very next thing that we want to do is we want to go to the CLI, or the command line. And there's a couple ways you can do this. You can type diff or diff all or dump. But basically all I want to do right now is to capture what's currently on the flight controller before I start messing with it, just in case I need to revert back to it because I messed up in some way. So what I like to do is I just type the word dump, and all of this information that's currently on the flight controller comes up. I'm going to copy and paste this into a Word document and save it on my computer. Where is it? That's the first word I typed was dump, so I'm just going to go down here. Now on here you notice that the version of BetaFlight that's installed is 3.2.3, and at this point that I'm making the video, the current version I believe is 3.5.2. So we'll be uploading the current version 3.5.2 here in a minute. You'll also notice that the target flight controller used by HDLRC F4 in this case is the Omnibus 4 or OBF4. We'll need to keep that in mind when we do the flashing of the BetaFlight firmware. So for now, I'm going to copy this, and I'm going to go to my Word file. I'm going to paste it, and it comes out where you can't see it. So what I need to do is make sure that I can see it by making it black, and then I'll just go File, Save As, whatever, in whatever folder I want to save. But that way you've got the original stuff that came with the flight controller saved to your computer folder somewhere, so that if for some reason in the process of flashing the new BetaFlight version onto the flight controller or setting it up, we mess things up in some way, we can always revert back to what was originally on the flight controller and start from scratch, which is a nice thing to be able to do. Okay, now we're going to flash the firmware. Quadcopter's in DFU mode. You can verify that by checking up here. All I did to get it in DFU mode was hold down the boot button on the flight controller while plugging in the micro USB into the flight controller. So firmware flasher, we're going to select our target, which is Omnibus F4. Right here, firmware version 3.5.2. Gonna load firmware online. And then we're gonna flash firmware. You can see down here it's flashing. Actually, it says erasing right now, so we're erasing, and now it's flashing. And it's been verified, programming's been successful, and now we have the latest version of BetaFlight on the flight controller, version 3.5.2. Okay, after we flashed the latest version 3.5.2 of BetaFlight onto the flight controller, we disconnected, and we're going to reconnect without pushing the boot button. Connect back. Under ports for this particular flight controller, we're going to have UART1 is our serial RX. UART3, we're making IRC tramp. Save and reboot. Let's go to the configurations tab. And we need to enable soft serial, which is here. And then we're going to save and reboot. Since we connected our smart port from our RXSR receiver to TX6 of the flight controller, what we need to do is find out what pin TX6 is on. We do that by typing in the word resource, and we look for TX6, and it's right there. TX6 is on pin C06. So I type in resource serial underline TX11, where 11 is for the soft serial number 1, C06. Let's go save. Save and reboot. Go under ports, and we have serial RX UART1, IRC tramp UART3, soft serial 1 is going to be smart port. We are good to go with our smart port for now. Okay, so now that we've got our ports set up with UART1 being our serial receiver, UART3 is IRC tramp, and soft serial 1 is our smart port, we're going to go ahead and over to the configuration. Now this 4-in-1 ESC on the F428 is going to be running DShot 600. We're going to go 8.8. We're just going to leave those the same. Craft name is going to be Ascent X 2.5. Don't worry about the camera angle. We need to set our receiver. It's going to be serial based receiver. S-bus. Air mode I want on. Anti-gravity on. Dynamic filter we want to leave on. I'm just going to leave all these at default. Our board and sensor alignment, remember we changed that earlier to 90 degrees because I rotated the flight controller 90 degrees in order to get the battery cable sticking out the back end. Arming, we want to change this to 180. And the reason we're going to do that is in case we have an unintended landing in an awkward position, which is greater than 25 degrees or 20 degrees, whatever the default was that I just changed. I want to be able to arm the quad and try and get out of that awkward position by flying out of it. In order to do that, I want to be able to arm the quad whenever I want to at no matter what angle it is currently sitting at. You have to be careful that you understand what you're doing there, because when I do this now, that means I can arm the quad when it's in a dangerous position. So safety wise, you just got to make sure that you understand what you're doing when you do this. Everything else I'm going to leave default, and for configuration we're going to save and reboot. Let's go back to configuration, make sure everything's saved. D-Shot 600, 90 degrees, 8.8, Ascent X 2.5, serial based, S-bus, soft serial's on, telemetry's on, air mode's on, OSD, anti-grav, dynamic filter, all those are the same, and 180. So we're good to go with our configuration. Back under in configuration, we also, for the D-Shot beacon configuration, we do want to set up an aux channel to beep the ESCs. Even though we do have an external beeper, I wanted to have redundancy, so under D-Shot beacon configuration, setting up an aux channel on a switch to beep the ESCs, we need to set RX set to on, and then save and reboot. Let's take a look at our power and battery. Minimum cell voltage, I'm going to reduce that. I'll make that 3.1 and 3.3. No, I'll make it 3.2. There, that's better. We don't need to change anything on here other than that, so we're going to click Save. Okay, before we get into the PID tuning, I want to go to the Receivers tab, the Receiver tab first, and check to make sure that our channel mapping is correct and that all the channels are working properly with my controller. So we're going to swap this out. Okay, so now we're going to check out the channel mapping and to make sure all of our channels are working properly with the transmitter controls. So let's first of all take a look at the throttle. Midpoint should be at 1,000. I'm sorry, the minimum should be at 1,000. Throttle's at the minimum. We turn the throttle up to max, and it's at 2,000. We notice that this channel for the throttle is working properly and the endpoints are calibrated properly. 2,000 max, 1,000 min. Okay, now let's take a look at the yaw. The yaw channel is working properly. The minimum is at 1,000, which is nice. Maximum is at 2,000, which is perfect. Minimum is at, or middle is at 1,500, perfect. So we've got the throttle and the yaw working correctly. Now let's do pitch. Pitch at a minimum is 996, but the channel's working properly, and at the maximum it's 1996. Mid throttle is, or mid pitch is 1,500. Center is at 1,500. But what we do know is that the pitch is working properly. How about roll? Roll channel is working properly. The minimum is 1,006. Maximum is 2,000. What we can do is change these. Go to the outputs, and we said first of all, right now the roll is at 1498 center. So let's go down to ppm center. When I change that, it's at 1,500 now. It's hard for me to get this in here. Okay, now we want Roll minimum's at 1003. So let's go down here to and we're going to change that. We got to hold the roll to the left minimum, and at the same time we want to decrease the number by, whoop, that's good right there, 1000. So we're going to push enter. Now the roll's at 1000, center's at 1500, max is at 2000. Pitch 997, 1498, 1996. So let's change pitch. So we're going to exit out a roll and we're going to go down to pitch, edit. Let's do the PPM center first. 1498 is what is that now. And we're going to crank it up. Right there's 1500. Hit enter. Let's go to minimum. Is at minimum. Is at 997. First of all, we have to change it. There's 1000. Hit enter. Max pitch is at 1997. This is going to be tough for me to change while doing it all. 1997. Crank it up. 2000. Hit enter. Alright, so our roll and pitches have changed. Throttle's still good. Yaw's good. So based on that, all of our channels are mapped correctly with AETR. We don't need to change them to anything else. And the channel endpoints min, max, and center have been calibrated. So we're going to save this, and we're good to go to PID tuning. Alright, under the PID Tuning tab, we're going to break this down into two parts. The first part, we're just going to go over the PIDs and the various settings. And then the second part, I'll go through my rates because we're actually going to set up different rate profiles. So for PIDs, there's a gentleman by the name of Mark Sutter. I'm not sure of the correct pronunciation of your last name, Mark. I apologize if I got it wrong. But he provided us with some baseline PIDs for the Ascent X 2-inch as a starting point for PIDs for this Ascent X 2.5. Also, Albert Kim has got good video on a baseline 3.5 version of BetaFlight setup for micros. So what I've done to come up with the PIDs that I'm going to use for my starting point is I've combined the Mark Sutter's Ascent X 2.0 PIDs that he uses along with Albert Kim's baseline PIDs for micros, which he uses for 2 to 3 inch micros, and I've split the difference between the two. So for P, I'm going to start off with 37, 42, and 65. 45, 50, and 45 are going to stay the same. I'm going to make these 15, 15. That actually might be a little bit too high. Mark goes with 10s, 10, 10, and 0 here. Mark leaves these at 60, and Albert Kim punches these up to 80 as a starting point for his micros. I'm going to split the difference, and I'm going to make these 70. 7, 0, 70, and 70. As I mentioned, these rates I'm going to leave the same for now. We're going to shortly here come back to those and do different rate profiles for those. I'm going to make this 15, 20, 5, 0. I'm going to turn all these on, and I'm going to, for the micros, bump this up to 0.25. So those are the changes I'm going to make for the PIDs and the various settings. We're going to save those for now. Saved. go back to check them. Everything's saved, good. And then we'll go through the rates. Okay, now for the rates. I'm going to set up 3 different rate profiles, and you can think of them as 3 different speeds, if you will, or low, medium, and high. And the 3 rates are set up based on the type of flying that I'll be doing. So the lowest rates will be for if I'm doing racing or practicing racing around tracks or things of that nature. And I will also use the middle rates for practicing as well. The highest rates will be more for acro flying, freestyle flying. So we're going to set the rates up for profile 1. I'm going to leave RC rate as 1. Here I'm going to make this 0.4. This is going to be 0.27. And this is going to be 0.72. Just bump that up one more, like that. So these are our degrees per second max velocities, 333, 274, and 714. RC Expo I'm going to bump up. Watch these graphs over here as I do this. 0.2. See how these red and green lines moved up? I'm also going to make this 0.2. And you saw how the blue line curved up here. What it does is it flattens it out in the middle area when I do that. And I'm going to save that for profile 1. Then I'm going to go to profile 2. In my profile 2 settings, I'm going to leave the RC rates the same. I'm going to set this up to 0.68. I'm going to set this up to 0.48, and I'm going to leave this at 0.72, the same as the last rate, so that my max velocity in degrees per second are 625 on roll, 385 on pitch, and yaw is going to be 714. Once again, I'm going to change the parameters over here to 0.2, and you can take a look at these graphs over here change as I do that. Click Save. Rate profile 3, or my freestyle rates, are going to be 78, 0.78, 0.78, 0.72 for 909, 909, and 714.2, and 0.2. And I'm going to hit save on those. So if I go back to profile 1, you can see my max velocity rates. Profile 2 increased, and profile 3 are much more. So the difference between profile 3 or freestyle, you can see here is 900s 714, and profile 1 300 274 714. So PID tuning, we're complete now. We've got the PIDs for all of them and my 3 different rate profiles. We'll go ahead and set that back on 1. And next we'll be going over modes. Under ARM, we're going to add a range. We're going to go to aux 1. And if you look up here at this little yellow blip, for lack of a better term right now, it's over here on the left. When I flip my switch on my transmitter, which I've already set up to arm the quad, it goes over here. So when the quad is armed, I want to move this yellow bar over here, and when it's not armed, I want it there. So that's going to arm it, that's going to disarm it. I'm going to save that. Then my modes, I'm going to add a range for angle, horizon, and acro. I'm going to make this aux 2, which I've already set up on a switch on my transmitter. So in that mode, when the switch is down, I'm going to have it in angle mode, horizon, aux 2. It's going to be switches in the middle position. I've set it up on a 3-position switch. It's going to be there. Now I don't need to add another mode over here for acro, because if it's not angle or horizon, this little blip should be outside of one of those yellow bars. So when I flip the switch all the way up, the blip goes over here to the right, which means it's not angle, and mode is not activated, and horizon mode is not activated. Since neither one of those is activated, the blip's over here, that means it's going to be in acro mode, and we're going to click save. The beeper, I'm going to put on aux 3. You can see the blip moving over from the left to the right of the bar, from over here to over here. So I want to move this bar over here, and then when I flip the switch for beeper, it goes over to the right. I'm going to click save. And black box. I'm going to add range. My black box is going to be aux 4. So when I turn my black box on, the blip's going to be right in the middle. When I turn it off, it's going to be outside. So the black box is only going to be activated when I flip a switch on my transmitter. Actually, it's a potentiometer. And that covers the modes. For adjustments, we go to the Adjustments tab, and we'll want to turn this on, change this to aux 7 I'm going to use. And we're going to make it Rate Profile Selection. These are where we select our rates that we set up earlier by using a switch. And that's going to be on aux 7. So this first rate, which is going to be my race rate, I'm going to have there. Turn this on, aux 7. Rate profile selection right there. Slot 1, yep, aux 7. Good. And we're going to flip it to my practice rate, which is going to be in the middle. So we're going to move this puppy over here. So, race, practice. Then the next one we want to set up is our acro. Which is going to be active over here. And we need to make sure and turn that to aux 7. So those will be our rate profiles selections. Race, practice, freestyle. Whoop, got to change that to rate profile selection. And before we escape, we hit save. And we're going to go to modes, go back to adjustments, make sure that it did save. Race, practice, freestyle. We're good. All right, those were adjustments. And next we'll go to the Motors tab. All right, now we're going to go to the Motors tab. We're going to do two things here. The first one in BetaFlight, we're going to determine that whether or not the correct motor is spinning. So when we expect motor 1 to spinning, is motor 1 actually the one that's spinning, or is it a different motor? And then we're also going to take a look at the spinning direction. If the direction is spinning incorrectly, then we're going to change that in BLHeli Suite. So let's go to the Motors tab. I need a battery, hook up. Okay, now props are off. You always want to make sure the props are off when you do this. I'm going to click on I understand the risks. Props are removed. And we're going to take a look at this diagram up here. Motor 1 is this one. When I pull this slider up, motor 1 should spin. Let's see. No, motor 1 doesn't spin. Motor 3 is spinning. And it's spinning the improper direction. So, what we want to do, when I do slider 1 over here on the Excel spreadsheet, motor 3 is the one that's actually spinning. This Excel spreadsheet and what I'm going through here basically is what I learned from Joshua Bardwell's site. Motor 2, this one should spin. That does not spin. This one spins. That one's spinning the correct direction, but motor 2 should be spinning, and it's motor 1. So we're going to go back over here. Motor 2. This is motor 1. Alright, let's do motor 3. Motor 3 is this one here. This one should spin. We already know that it was spun on another one, on a different one. So when motor 3 should spin, motor 4 is spinning, and motor 4 is spinning the wrong direction. So when motor 3 when slider 3 is raised, motor 4 is spinning. So when I raise slider 4, motor 2 should spin, and none spin. So that's a major problem. But we know this one should spin. So we're going to map that to motor 2. Now that we have those, we're going to go to the CLI and take a look at resource. Motor 1 is resourced to B00. So pin number B00. Motor 2 is B01. Motor 3 is A03. And motor 4 is A02. So now what we want to do is we want to go down here and we want to say resource motor 3 B00. So basically we're going to take the B00 from motor 1 and put it onto motor 3. So resource motor 3 B00. Resource motor 3 B00. Hit enter. Motor 1 is now disabled and the resource is set to B00. Then we go resource motor 1 B01. Resource motor 1 B01. Motor 2 is now disabled and the resource is set to B01. Then we want resource motor 4 A03. Resource motor 4 A03. And then resource motor 2 to A02. Resource motor 2 A02. Then we want to type save. Then we want to go back to the CLI and we want to take a look at resource. Motor 1 is now B01. Motor 2 is A02. Motor 3 is B00. And motor 4 is A03. So our resource remapping was saved correctly. Let's go back to the Motors tab. Motors tab. And check it out. If we raise slider 1, motor 1 should work. It does. That's good. If we raise slider 2, motor 2 should work. It doesn't because something's wrong with that one. Figure out what it is and then come back and fix that. Motor 3 does work. Motor 4. So our remapping worked. So we're done with the correct motor spins when we raise the slider, with the exception of motor 2. And we don't know what that problem is yet. So we're going to have to exit out of here and figure out the motor 2 problem. Keep in mind that the motor's directions are not spinning properly. Motor 1 should spin clockwise. Okay, motor 1 is spinning counterclockwise, so we're going to need to change that. Motor 2 we know doesn't work. Motor 3 should be spinning counterclockwise. It is spinning clockwise, and it should be spinning counterclockwise. So motor 3 is spinning incorrectly. Motor 4 should be spinning clockwise. Motor 4 is spinning incorrectly. So all the motors are spinning incorrectly, and motor 2 doesn't work. But the right motor is now spinning when we raise the slider. So motor 1 is motor 1, motor 2 is motor 2, motor 3 is motor 3, and motor 4 is motor 4. So that's all we can do right now in BetaFlight. And then we're going to, later on, after we get done configuring in BetaFlight the remaining tabs, we'll go into BLHeli and try and fix the direction of the motor spinning. Prior to that, we're going to have to figure out what the problem is with motor 2. Okay, now we're going to the OSD tab. I'm going to set up the OSD. We'll leave the video format on. Actually, I'm going to set it up for NTSC. I want the RSSI value on, and I want it over here in the right hand corner. We can just drag and drop this wherever we want. I want that logo off. Main bat voltage I want on, and I want this over in the bottom right corner. I forget which one. Timer 1 is on time. I don't want that. I want timer 2, which is fly time. There we go. What else? Craft name. I want to put up in the upper left hand corner. VTX channel. I'm going to put up in the upper left hand corner. I want the warnings on. I don't care what my max speed was. I don't care what my max current was. Alright, and that'll set up the OSD for our Ascent X 2.5 inch. I'm going to save, and that'll do it for the OSD tab. Now we're going to take a quick look at our Blackbox configuration. Our flight controller has a 16 meg onboard flash, and it is on onboard flash. We're going to record at 1 kilohertz, and that's pretty much it for Blackbox. So we're going to save and reboot. And we're done with our tabs. So the next thing we're going to do is check out to see why motor number 2 is not working. It could be solder joints, so I'll take a look at those. It could actually be we got a bad motor, which if that's the case, fortunately when I purchased these motors, instead of getting 4, I got 5 spare just in case, because these motors, a lot of quadcopter parts come from overseas and take 3 to 4 weeks to get here. So instead of 4, you want to get 5. Get a spare of everything that you can, just in case you get a bad one, or you happen to break one. Then you've got one on the shelf ready to put back in. Okay, I've got good news. I think I've found the problem for motor number 2 not spinning. In my attempt to keep the flight stack as low as possible in height, it was actually too low, and the bottom of the ESC was touching the battery strap and or the carbon plate of the main frame. So I went ahead and raised the stack up by inserting another washer on top of the screws that the ESC sits on top of. So the ESC I raised up just by 1 washer width, and that seemed actually to do it. So we're going to check it out here. We've got the quadcopter connected to BetaFlight, batteries connected. So we're going to the Motors tab. Click I understand the risks, propellers are off. Raise motor number 1, which is this one right here. Motor 1, 2, 3, 4. Let's check out motor number 1. And motor number 1 spins. Motor number 2, let's watch to see if motor number 2 spins, and we've got it fixed. I know, right? I'm pretty happy about it myself. Motor number 3. Spins, that's a good thing. And let's see, motor number 4 spins. Motor 4 spins, that's a good thing. So all 4 of our motors are now spinning. All 4 of our motors are spinning incorrectly, in the wrong direction. So now we will go into BLHeli Suite and change the direction of the motor spins. Okay, now we're going to go into BLHeli Suite and change the motor direction on all of our motors since they're all spinning incorrectly at this particular time. The first thing we're going to do is connect the quadcopter to BLHeli by hooking up the micro USB. We're going to connect. Then we're going to connect the battery. We're going to read the setup. Found multiple ESC configuration in Scilab's mode. You'll notice here ESC 1, 3, and 4 have Rev 16.7 for the BLHeli version. That's because prior to this I went ahead and flashed those ESCs. ESC 2 has 16.6 because actually I was not able to flash ESC number 2 at that time because ESC 2 was not readable because of the problem with the motor. So at this time we're going to go ahead and flash ESC 2 with the latest version of the firmware, Rev 16.7. Flash BLHeli 16.7 to ESC 2. We don't want to change any of this. The latest version available is 16.7, so that's the one we want. I'm going to hit OK. Do you want to flash target ESC 2 to 16.7? Why, yes we do. ESC number 2 flashed file successfully. So now we have a summary saying ESC 1, 2, 3, and 4 are all at Rev 16.7, and that's exactly what we want. Good. So now what we want to do is we want to change the motor direction on all of the ESCs. So for ESC number 1, we want to change this from normal to reversed and write the setup. We're going to right click on motor number 2, ESC 2, reversed, write the setup. ESC 2 is right, okay. We're going to right click on ESC 3, ESC 3 shows up. We're going to reverse that, write the setup, good to go there. And then we're going to right click on motor number 4, ESC number 4, change that to reversed, write the setup, ESC 4 right is okay. Check. And now we're going to disconnect. Disconnect the battery. Disconnect the USB. Now we're going to go into BetaFlight and check the motor direction to ensure that they're all spinning correctly. Go to our Motors tab. Acknowledge the fact that we've removed the props and understand the danger in this. We're going to check motor number 1. Motor number 1 should be spinning clockwise. And it is. That's a good thing. Motor number 2 should be spinning counterclockwise. It is. Motor number 3 should be spinning counterclockwise. It is. And motor number 4 should be spinning clockwise. it is. All 4 of our motors are spinning, and all 4 of our motors are now spinning the proper direction. All of this is a very good thing. At this point, we're done setting up our motors, and we're done setting up our quadcopter, the FlexRC Ascent X 2.5. Now we're going to put it back together, make it look sharp, and get ready for its maiden flight.
Alive! It's alive! It's alive!
Alright, having completed the setup, our little Ascent X should be ready to go. Next video, we'll take her outside for her maiden. We'll see you then. Happy flying!